So this equation 2 has a co-squared. So we have to ask ourselves, could I get that co-squared by itself, or is there another cos in the equation? In this case, there is another cos in the equation. So we're going to use our, how do we solve quadratic equations when there was an x squared and an x? We made one side equal to 0 and then we tried to factor or use the quadratic formula. So I'm going to move everything over to the right side. I don't like dealing with cos-squared when it's negative. It makes it a little bit harder to factor. So I notice my cos-squared is negative on the right side. So I'm just going to move everything to the left side of my equation by adding 3 cos-squared to both sides. Still have a cos x on that left side. Subtract 1 on both sides, and then I'll have my equation equal to 0. So at this point, you have a choice. You could try to factor it, and if factoring is not working for you, you could go to the quadratic formula. Okay? I'm going to try factoring it. If I start and I have a 3 cos squared x, the only way that would be possible is if I had a 3 cos x and a cos x. If I have a 1, the only way that's possible is if I have a 1 and a 1. Now what happens if I check my outside and my inside at this point? My outside is 3, my inside is 1. Does that ever make 1? No. So at this point, it's not possible to factor. I just was doing the factoring as a check only to find out that I can't factor. So then my only option is to use the quadratic formula. Okay? Quadratic formula, new this year, is on your formula sheet. So that is good. Otherwise, you'd have to have it memorized. So now I'll have cos of x equal negative b, negative 1, plus or minus the square root of b squared minus 4. A is 3, c is negative 1, over 2a. Negative 1 plus or minus the square root of 13 over 6. So this means we have 2 answers right now. We have one answer where you would use the positive and one answer where you'd use the negative. And we're going to actually put this into our calculator and get the values and work from there. So if I use, while that's warming up here, here's our positive one. Here's where we use the negative answer. Negative 1 plus the square root of 13 divided by 6. That comes out to 0.434. So if I go back to here, this one gives us 0.434. That's positive, so it could happen in quadrants. Where? 1 and 4. Okay? This is a good example of where you're working with your calculator, where you can sometimes get confused with the answer you get here and think, oh, 0.434 is my reference angle. I'm going to see what answer we get for this. But what this means is you can make that a fraction as 0.434 over 1. And if you think of that as adjacent over hypotenuse, That's what it would look like, and you have a little reference angle here, which is going to be exactly the same as the angle in quadrant 1 anyways. So when we go to find our reference angle, oops, okay, I'm going to go cos inverse, and instead of typing this in and rounding it early, because rounding early could cause you to lose some marks if it changes your answer, I'm just going to get the answer from that. And my reference angle in radians is 1.21, 1.12. So my reference angle is 1.12. And then my angles here in quadrant 1 will be 1.12. Did it say to the nearest hundredth? Yes. 1.12. And in quadrant 4, you would go 2 pi minus that reference angle. So those are our answers from 0 to 2 pi. Of course, in this one, what is it asking for? From negative pi to pi. So negative pi would be looking this way. Pi would be, 0 to pi would be looking this way. So our actual answers that we're going to circle in the end, well, we're going to include 1.12 because that's the positive answer between 0 and pi. And the 5.85 is the same as our negative reference angle, negative 1.12. So those will be the answers between negative pi and pi. And we've solved the first part, where from our quadratic formula we had the positive sign. Now, we're going to do the same thing for this one. Again, some calculator tricks. If you go up and highlight what we wrote before and push enter, it retypes it for you. And then just go to that plus sign and change it to a subtract sign. Did I hit the subtract sign? There we go. Push enter. That's nice and short. If you don't have that option on your calculator where you go up to get something, you can always get things that you typed by going second, enter, and it'll just keep toggling back until you find the one you want. So the one that I wanted, here it is with the negative sign. We get negative 0.76. This time I'm going to store it as x. Oh no, yeah, I'm going to store that as x right now. And that is not our reference angle, that's just what this is equal to. 716, 7678. Now cos is negative. So according to our cast rule, that would be looking in quadrants 2 or quadrants 3. If I draw a picture of it in quadrant 2, I can make this a fraction over 1. So adjacent over hypotenuse, and here would be my reference angle. So to find my reference angle, that's where we use our positive values. And I'm going to do cos inverse. So I'm going to do, well, I'm going to take this, because I want that as a positive number, 0.76. Sorry, guys. I'm rounding here. It was bad. So it's helpful, because if I just use that answer that I have there, I have a negative answer. And I want to have the positive answer to find my reference angle. So when I go cos inverse, if I just type in x, that's going to plug in negative 0.77. And I want to plug in positive 0.77. One way I can do that is if I know x is negative and I want to make it positive, does it make sense that I could times it by a negative, and that would make it positive? That's probably the easiest way to do that. and then I get my reference angle as 0.70. This is where you have to develop some confidence because the numbers that we're dealing with are very close to what we had before. We had the ratio as 0.77 over 1, and now we found the angle to be 0.7. I've seen on a final exam where the ratio and the actual angle are off by 1 decimal place. So it just messes with your brain a little bit because you have to make sure I know what I'm working with and I know that what I'm dealing with. Now I found my reference angle. Now I can find my answers for x. There's going to be 1 in quadrant 2. So there, I'm going to store this. My reference angle is x. So in quadrant 2, it would be pi minus my reference angle. And in quadrant 3, it would be pi plus my reference angle. So I have 2.45 and 3.84. And those would be my answers from 0 to 2 pi. This is asking, again, our little diagram with the blue and red here off to the left. It was asking between 0 and pi and 0 and negative pi. So we'll get the 2.45. The 3.84, if we subtract 2 pi from that, will be negative 2.45. Another way that I could think of that is if I'm looking here in quadrant 3 and I know that that's my reference angle, this negative angle would be the same as this angle going to quadrant 2, just in the negative direction. So that's how I knew it would also be 2.45. So now we have our solutions between negative pi and pi. That was only part A. And then it said, determine the general solution. Well, for the general solution, for part B, we take all of our answers from 0 to 2 pi. And that was why from 0 to 2 pi was here and here. We write them all out. 1.12, 2.45. If you want to be pretty, you do them in order. 3.84 and 5.85. Squiggle brackets still. Whoops. And then you add 2k pi to each of them. You for sure need to know your calculator to be able to do these. So they like to put something like this in the first 8 questions of your final exam, because they have about between 6 and 10 questions on your final exam that are calculator, and they want to make sure you have to use your calculator. So this would be an excellent example of where you would have to use your calculator. And the question said use algebra. If it didn't say use algebra, if it just said solve, I think it would be much easier to type this into y1 and this into y2 like we've done before and find out where they intersect, because you'll be able to solve from 0 to 2 pi where they intersect within a matter of a couple minutes rather than how long this took. But because it said use algebra, this is what you have to show. If it just says solve, that allows you to choose your technique graphically or algebraically. Okay, the questions you can do from this one are 12, 13, and 14.